Good afternoon. Oh, wow, that was a tad louder than I expected that to be. Thank you very much. That's just woken me up for the afternoon. Right. First of all, I just want to thank everyone that's come along to this session. We're really excited about this session. For us at Elcrig, you'll have noticed this year that we've got a lot more startups. We've got a lot more sort of universities. We've got people bringing new bits of innovation. And it can't have escaped anybody's notice that the autonomous pothole filling machine has been on news and BBC and all sorts of different things. And one of the things we can do at Elcrig, being a community interest company, is that we can use some of the the funds that we sort of receive from the events and things we do to support companies like these guys to come along and exhibit to sort of new audiences, get feedback on their products and the sorts of things they're doing. And I think for us, it's also part of that, making sure that each year we continue to try and bring new innovations, new sort of discussion points. And I can't think of a bigger discussion point than what you guys are going to talk about this afternoon. So without further ado, I'm going to hand over to Mike and Paolo from Roboticized. And do listen. It's going to be very intriguing. I know you're all very, very intrigued. And thank you very much for coming.
Great. Thanks very much, Paula. It's going to have to be good now, isn't it, after that introduction? So if I disappoint, I apologise now. So good afternoon, everybody. Welcome. For those of you who don't know me, my name's Mike Harper. I'm here with my colleague today, Dr. Paolo Paoletti from Liverpool University and also from Robotized. So together, we're going to introduce you to some new technologies, but also a new name in the industry. So Robotized, before you got the information for this event this afternoon, how many people had heard of Robotized? Quick show of hands. No, I'm not going to be knocked over by the draft, am I, from that? So so hopefully we're here to certainly, as Paula said, explain what we're about and also who we are as a business. So we're a spin-out company from Liverpool University. We're headquartered at the Daresbury Innovation Park in Cheshire. One or two of you might have seen some of this on the news recently. As Paula said, there's been a lot of interest in this for prevention of potholes in particular. The BBC picked that up, and we did a feature with them a little while ago and quite a lot of the news channels. So you might see bits of video kicking around online. The company's mission is to bring new developments in artificial intelligence and robotics into our industry, but in a practical way with some end-use applications. So simply, we want to reduce the number of potholes on our roads and improve network condition by harnessing the advances that are now out there in technology. So I think it's probably not too controversial to say that we're in a bit of a deteriorating condition, aren't we, from a national road network point of view. Despite all our best efforts, despite all the best practice that's out there and the great treatments and materials that are available now, for a number of reasons. The alarm survey shows us that it's 16.3 billion would be that one-time catch-up now that we measure each year. But what's more significant about that, from my point of view, is that that's increased 6 billion over the last 4 years, quite progressively. So for all the good stuff that we're doing, we're still struggling to get that backlog down. As well, 2 million potholes filled next year. Well, hey, that's a new record, or that's the highest number since 2016. So that's great, 2 million potholes, well done. Fantastic. Or is it? Or is it a reflection of the amount of potholes that we're having to fill because of the condition of the network? It partly is. It's partly exacerbated by funding issues, of course. It's partly exacerbated by wetter winters, higher traffic flows, and none of those things are going away, are they, going forward? So how do we get ahead of it? Many of you might know me from my involvement with the RSTA and with Elcrig in previous years. RSTA has always advocated for the right treatment in the right place at the right time of year in order to get the best out of our highway network, and I strongly agree with that. But how do we know exactly when the right time is to intervene? So I don't know how well you can see these graphs, but thank you to the RSTA, Paul, for lending me this graph, if you're here. On the graph on the lower part of the slide there, we've got our red, amber, green, nice and familiar up the side, years along the bottom, and we anticipate some sort of deterioration in asphalt performance over time. And then what this slide suggests, it's talking about surface dressing in particular. Many other surface treatments are available, not picking that one out specifically, but we intervene in some way to get back into that green zone, and then we'll expect some sort of deterioration again. But in reality, how do we measure that? Because if we're scanning our networks, for example, we might scan a third of the network each year and then move it around to different roads. So we might only, in those curves, have 2 or 3 data points, because it's expensive to do and time consuming. So what we're really hoping to do is populate those curves with more data for you so that you can better anticipate when to intervene. So I would suggest, for example, these are nice curves. I would suggest that maybe some of those curves are flatter for longer before they start to tail off. So in terms of hitting that sweet spot of when you want to intervene with a treatment or major maintenance, we want to give you more information to be able to interpret that more exactly. So, just one moment, I've lost my place. I'll just do the Boris Johnson's. Anybody been to Peppa Pig World? We've seen that, haven't we? So, what we're about to show you is a method for providing highway authorities with more high-quality information about your road networks so that you can choose when to intervene. However, whenever we talk about this with local authorities and more data, many local authorities say to us, whatever you do, don't bury us in more data because we don't have the resources to deal with it, which is a real concern, because if it's just raw data, then sure, the answers to your questions are in there somewhere, but how do you interpret that? So one of the big steps in this is the use of real AI in order to give you answers to those questions, in order to help you categorize the defects that we're identifying. So to give you better information, processed information for decision making, rather than large volumes of data necessarily. So to explain that in more detail and to see what that looks like in reality, I'm going to hand over to Paolo, Chief Technical Officer for Robotize.
Hi, I'm Paolo Paoletti. I'm the CTO of Robotize and also one of the co-founders. And I'm going to go a little bit deeper in the what we provide in terms of the vision that Mike just outlined. So we need to know where the defects are, what the condition of our road are. How can we do this? We looked, when we founded the company, we looked left and right in available sensing technology that can provide this kind of information, high quality data about our road, at a price tag, if you want, that is affordable to do this more routine inspection and having more updated real-time data about our road. And we couldn't find anything, so we ended up actually developing RSI, which is a little box. It's on our stand, if you have visited our stand, stand 5, in the exhibition. It's a box that can be retrofitted to any vehicle. It's a standalone product, if you want. It is powered by AI, so all that the driver needs to do is to put this on the roof rack, turn it on, and just go around and do their daily job. It doesn't need to be a dedicated vehicle or anything like this. It has a patented technology to actually reconstruct the surface of the road with millimeter accuracy, and whenever there is a defect, there is the AI that isolates that defect from the rest of the road, and it tells you this is a pothole, this is a longitudinal crack, this is a wheel crack, this is a ironwork, so this is a manhole, this is a drain, whatever. And then it can also, to help in the decision process in terms of prioritizing intervention, it can also assess the severity of these particular defects, and we can tailor the severity classification according to the different criteria that different councils have. So how do you use this data currently? So you put this little thing on your car, it goes around, and what you get as a if you want, from the local authority point of view, you get access to the data, something like this. This is our user interface, where you have the geotagged defect. It goes on a map so that you know where it is. And for each of the defects, you have a visual representation, which is the top image, if you want, but also what our system actually see in terms of depth. And this is not vision-based, it's based on laser triangulation. And the key things about this is that given that we are not vision-based, we can get very accurate measurement of the road surface at up to 60 miles per hour, weather independent. We can work night and day because we don't need external illumination or anything like this. And what you see in the bottom two boxes is just a visual representation of what the real data looks like. It's not an image, it's not an RGB image, a true RGB image. And then our AI process this data and identify, in this case, a little pothole here. And for that particular pothole, it gives you latitude and longitude, width, area. You can even estimate the volume of this so that if you are going to do an intervention, you can assess how much material, for example, you need to do that intervention. So again, we see this sensor as a way of getting more updated data and more frequent data so that you can start populating the curve that Mike was talking about, so that you can plan your intervention better and in a more timely fashion, if you want. And hopefully this will reduce the cost of that intervention because you can do early on. And also the safety of our network, and also the environmental cost because we are going to use less material, which we know are quite carbon heavy, although there are quite a lot of innovation, if you see, in terms of decreasing the carbon footprint of the materials that we use. So in terms of getting the data, this is our product. Then we can go even a step further, and this is what went into the news. You can do something more autonomously. So we can take the same box that you can put on your car or in your vehicle, we can put on an autonomous vehicle that we call RS Prevent. This is a fully autonomous, there is no driver in it, and it has RSI in it to detect the cracks and potholes and all the defects. And when it identifies a crack that needs repair, it can actually stop and do the repair on the fly, and then off we go. This is really possible by using some of the more modern technology. So there is the artificial intelligence on the eye that does quite a lot of the heavy lifting in this process because it identified potholes and it tells actually the robot where to intervene. And then these get translated to, basically there is a robotic arm at the back that it's like a giant 3D printer, if you want, on wheels. So we can actually do the crack repair like a surgical operation just by following the silhouette of the crack, so that we don't have overbanding, we don't have spillage, we don't have all the problem with skid resistance that you might have. And we can do this for very fine cracks in a cost-effective way. This, just to be completely transparent, this is a prototype. We have been trialing with Harper. That's here. So it's, and we're going to demo tomorrow at 10:30. If you are interested to see this live, we will be on the road there trying to fix some cracks. But this is a prototype. It doesn't have the, if you want, the certification that you need. You might imagine you need to have an autonomous robot on your road. And legislation is still catching up. So, for example, this will have to work in a isolated section of the road for a moment because it can't work in real traffic. The robot is capable of doing this, but legislation doesn't allow us to use it that way. And I think that's what we, they are the two main products, if you want. RSI is available, so whoever is interested, we are looking for trials opportunities or people that actually want to use and scan their network. Prevent is more on a prototype stage. If people are interested, we can showcase, we can come to you and do some demos to your case, but it's not a commercial offering. And then I'll hand over to Mike as well for the last
Good.
Thank you. Thanks, Paolo. So that's all about what we wanted to say, but there's been lots of interest in the robot, of course, today. So can I invite any questions on any of that?
Well,
Stunned into silence. Yes, please. Go, Sean.
you talked about you're not dependent upon lights in day.
Yes.
What about the weather? I'm thinking specifically wet weather. How does that impact?
Yeah, I'll let the technical man answer that.
Must be stolen by the microphone. So we can work with sunshine. We can work with a little bit of wet on the road. If it is fully flooded, but there is no sunshine, we can still detect the defects. We lose a little bit of accuracy in terms of depth because the light reflects in a different way. The worst condition is that where there is the thin film of water on the road and it becomes like a mirror, and then it's when basically we start having some issue in terms of accuracy, because it's whenever you look at the road is also when you're driving, it looks like a mirror, so it's very hard to actually see the road in that case. But that's the only, if you want, condition that is problematic for our sensor.
Diane, we're North Somerset Council. Do you do the vertical assets as well? Can you pick up defects on signs and like signposts? And
not at the moment. It's in the pipeline, but at the moment it's a bird eye view, so we only look at the road surface.
So Thomas from Birmingham City Council. Do you also look at footways, or is it just the carriageways?
So we had an interesting conversation this morning. We never thought about footways. So in principle it can be used, but we never tested it on footways and this kind of thing. So there is some technicality in terms of, given that we are using lasers, if you lower the height too much, like something, we need to lower the intensity of the laser, otherwise it doesn't become safe anymore. But decreasing the power is trivial, is increasing that is tricky, if you want. So it's a modification that will take very little to do. But it's an application that we never thought before. It came up today.
Second question is, you did say that after the inspection, it can quantify the amount of material that you need for a pothole. But is the quantification only for potholes? Does it go to areas like you notice that there are loads of alligator cracking that you will want to sort of like quantify the area that you want to sort of take out and replace? Does it do any quantifying of other defects?
So at what you see on the user interface is the area and the volume of the crack, if you want. But what in the back end our system does actually draws a bounding box on it. So in case you need to actually cut the asphalt, I think what you're referring to we have this information in the back end. At the moment it's not exposed in the UI, but the system actually has that information. So if people are interested, we can output it.
Any more questions? I can't believe there are no more questions. What's the question you most get asked?
I think the one that's come up most often today is can we interface with Confirm? So at the moment, the way it's set up as as Paolo showed, there's a user interface that's bespoke from us. So we'd be interested to talk to all local authorities about this, about the systems that you already use, and whether you want to see a standalone system as a user interface, or whether you want to see it feeding into the systems that you've already got. And if it's the latter, which it seems to be very often, which systems are you using? So we've had quite a few on Confirm this morning, and the other one was the one that came 70. There was another one anyway, I can't remember the name of it now. I've got a note back on this stand. So what we're interested in there is if you're using a system and you want our information to be imported into that, we just need to know what that is so that we can identify the right code or whatever you call it. That's a technical term, to make sure that it feeds in and everything works together. So that's probably the thing that's come up most this morning.
Brilliant. Any other questions? I mean, I would remind people. Oh, excellent.
How much material does it hold? I've got my voice.
It's about 200 liters of repair material on the robot.
And what's its battery life? So if I'm going to send that out with my plan to get it to fix as much as it can, how long does it last?
Well, it depends on that's a tricky question. So, because it depends on the density of defects that you need to repair and how often it needs to stop and using the pumping system and so on. So, the vehicle itself, if it doesn't have to repair, will last around 10 hours. The pumping system, it lasts about 4 to 5 hours, continuous use. But of course, it's never continuous. So, it really depends. But these are more or less the ballpark figure.
Any questions? Adam from the utilities sector, putting you on the spot there.
Well, I think the only question for me was Adam from the utilities sector. I think the only question for me was, can you only do one pass with it, or do you need, standard width carriageway? If you're using it on a vehicle, do you have to go down one side and then come back up the other side? I'm guessing it only scans one side of the road at a time.
We scan one lane at a time. So it's slightly more than 3 meter width in terms of scanning width. So it's one lane, basically, effectively.
And it's the only other question I had was it only picks up the surface. So it can't pick up any degradation underneath the surface, like any failure within the binders or anything like that. It's not scanning below the surface layer, is it? It's just...
No, there is no... Yeah, no, not at the moment. Let's put it that way. We are thinking in terms of integrating ground penetrating radar and this technology to see what's happening underneath, but it's not part of the system at the moment.
Well, that was going to be my next thing. Yeah, it is available. You maybe want to join.
Yeah, we were talking with TRL in terms of integrating these two systems together so that we can have the bed-wide view, but also the underground view, if you want. But it's not something that we have been actively working on so far.
Right. Okay. Thank you.
So just a show of hands, who thinks, just as falling out the tent, who thinks that this could well be the future of what we see on our roads? Hands up. Oh, look at that Hertfordshire first up. Well, it's about 50-50. So those that didn't put their hands up for the other 50%, why do you guys not think it might be on the roads? Who wants to just chuck in a point there?
Hi. I think my kind of issue would be, knowing where I'm from, it getting nicked or getting damaged whilst it's out there.
What do you say to that then?
Yeah, I'm not sure how to respond to that. Firstly, I'm not going to ask you where you're from. Don't want to put you on the spot. Like anything, it can be made secure enough. I guess this is a prototype at the moment. We haven't built a load of safeguards into that other than that if you don't have the remote control box, it's not going anywhere. So I guess it's no more a risk than any other piece of plant necessarily, but it's pretty much switch offable and
there is
lock off.
It's fully autonomous, but you can always switch off with a big red button remotely. And the reason why it's not commercial offering is because of all this certification that we need to have in terms of making the safety case and so on. So it's something that we are aware of. At the moment, having a remote switch, it's a requirement because it's the safest. To some extent, it's line of sight. You simply switch it off. In the future, we might have to have something more sophisticated to some extent. We are talking with a few standard and regulation body in terms of actually what kind of certification we need, because it's a tricky one, because some people think it's an autonomous vehicle, people think it's a moving plant, and the kind of regulation that you need to satisfy are quite different. And nobody has told us, not even BSI, actually you are this category or this category. So we are still mapping actually where we fall into, and that will determine all the safety that basically we need to integrate in the vehicle.
Yeah, I think Will from Essex, I'm not from Hertfordshire. But I think the eye and the prevent are definitely where it's going. You're going to get autonomous survey probably as well on top of that. And it's autonomous plants, and more plant become autonomous or semi-autonomous. But I don't think it takes away the need to do capital maintenance where you're actually, essentially replacing the surface itself. You're going to get as much out of it as you need to, but there's a point where what you're doing with prevent isn't going to be working. And I know that you're working on the next stages beyond that as well.
And the idea is actually prevent will delay a little bit the point where you actually need to do, for example, resurfacing and this kind of thing. So it's about extending the lifespan. It's not that potholes will go away forever if the prevent is on our road, and so we're aware of it.
Yeah, there's always going to be that threshold, and we'll have to learn where that happens to be.
Yeah.
But you might get less defects appearing because you've stopped that water ingress earlier, maybe.
Yeah.
Yeah, that's exactly it. And in common, really, with any surface treatment, no treatment's going to fit everything. So it's kind of like surface dressing, for example, isn't it? So or patching. So if you're patching a road, you might get to the point where is it about 15% of patches that cut off, where you think, right, okay, it's a resurfacing job now. And similarly here, so you might get to the point where there's cracks absolutely all over the road, and then it's a resurfacing job, or it's potentially it's geogrid or it's reconstruction, etc. So this is really about identifying the cracks, and because we can get this equipment out there more easily because it's more mobile, you can get more information as to how that's progressing over time. So you might have cracks in a type of asphalt which isn't really progressive. So just keep a watching brief on it, see how it goes, because now you've got more regular data. You might have an asphalt type which, once it starts to crack, really starts to fail quite quickly, and then you'll have not only visual of it, but you'll have quantitative data of how that's breaking up. So you'll be alert much more quickly, hopefully, that there's an issue and when to dive in. But yeah, there's no way to fix all types of road defects. This is another tool in the box in terms of trying to get ahead of that pothole problem and try to get away from this reactive maintenance, because now you can see it forming and jump in a bit earlier and hopefully save lots of material and some money.
Hi, Sean Rooney from Oxfordshire. I've got a comment and a couple of questions. And to partly answer the question as the 50% that didn't say it's going to be on the road, I think there's a piece of work to do from a sector mentality. Is that change? We all love something different, don't we? And we all embrace it with eager anticipation, don't we? And I think part of that is, one of the questions from myself and, I'm sure others, the material longevity of this. How long does the material that comes out of the poop box at the end, how long is that? The cost side of things, how does it compare to the other mechanisms that are available out there? And as you said, Mike, it's one size doesn't fit all. And this may be useful for someone, but not for others. So I think, there's some of those that needs to be addressed. But that's me being positive. As you know, Mike, I'm a very positive person.
I'll brace myself.
Yeah. But the question from a technical perspective as well is, what's the success of correlation? So the defects that it's identified, what is the success factor of, yes, we've repaired all the defects, and yes, we've repaired the right defects. Were they defects in the first place? Or are you just graffitiing with the pooper box at the end in terms of the way forward? And a supplementary question, we all badge, and there's a really interesting conversation coming up tomorrow afternoon with Paolo and myself. Is it truly artificial intelligence, or is it more algorithmic against set parameters?
Right, I'll definitely let Paolo take that second one. My understanding is it is, but Paolo will give you the real detail. In terms of materials that you were talking about before, material choice is an important one. So at the moment, the material that we're using may not be the material that we ultimately use in the final product. So we're talking to material manufacturers about that at the moment to select the best way of doing it. There was a question in the middle there. Just remind me, because I'm having a Joe Biden moment now.
No, that's fine. Peppa Pig World is very good. I've got a few. So whether it's material longevity, cost prohibitiveness, not one size fits all, changing the sector mentality, and is it truly AI or algorithmic?
Yes. So the change of mentality one was the one I was trying to remember. That's an interesting one. So we have had a couple of comments. This might have even come from Hertfordshire, possibly, about crews being concerned about being out of work effectively if a robot comes and takes over our jobs. Unfortunately, I'm old enough to remember the 1980s when robotics started to come into manufacturing in a significant way, and everybody was concerned that we'd all be working for Costa Coffee within 15 years because it was going to take all our jobs. Yet here we still are, possibly with more sophisticated jobs than we used to have. But I can't see a point where it's going to take the need for the human element out of it completely. This is another technique that we've got alongside all of the other things that we need to do. What we hope this is going to provide is a way of treating more of our network within our budgets. That's what we're looking to achieve. I don't see that it's going to take the human element out of it ultimately. There's still plenty of things that we need to do out there, not least interpreting what's going on. And you did mention earlier about the types of things that it's identifying. So we can set those criteria as well. So if in Oxfordshire, for example, a pothole constitutes 40 millimetres or greater, we can put that in. If you're more concerned about wheel track, for example, perhaps you're thinking 25 mil in the wheel track, 40 mil in the oil lane, perhaps, then we can put that in as well, so that it's not giving you false positives in terms of categorizing your most important defects. It's categorizing them in the way that you had told us that are most important to you. And similar with cracks. So look at any asphalt, look at the roads through here, particularly that one over there, absolutely full of cracks. Would you try and repair every crack in that road out there? No. Personally, I'd go and surface dress that probably, because there's cracks everywhere. Discrete cracks, though. So it's a case of how deep and how wide, perhaps, is, what's your criteria for the ones that we should be doing, the ones that we shouldn't be doing. We can set that, and then we can have it categorize those for us as it goes along. So it shows you exactly where your category of crack to be repaired is. And for the other bit, I'll let you answer.
And I think this connects on the question, is it real AI or a set of criteria? So we consciously put AI only in the separation of the good piece of the road from the defects. That's true AI. It's a neural network type of stuff. We can talk about the technicality first. But then when we come to the severity classification, given that different councils have criteria for that, that's not AI. Otherwise, the AI will learn a dumb task, which is learning your criteria. So in that case, it's just a set of criteria that we set according to the customer requirement. So it's a mixture of the two. We give the AI the difficult bit of identifying defects, where having just a set of criteria really doesn't provide a lot of reliable identification. And then in post-processing, we assign the severity, we do the calculation of the volume and everything on what has been identified by the AI.
Just got one more question. So what we can see is a prototype at the minute. So when it's fully developed and fully formed, how will it function? Will it just leave the depot and go and do for a day and then come back, or is it gonna live in a geotagged, chaperoned area? How will it work?
So it depends a little bit on how the legislation evolve. The vehicle itself is capable of saying you need to cover this area, and it navigates around the area. It has radar to see if there are other vehicles and so on. So that, in principle, I don't know how much familiar you are with the level of autonomy definition. It's up to autonomy level 4, which is not Tesla type, which is level 5, but slightly below. Legislation doesn't allow us in the UK to do that. So realistically, unless the legislation goes super fast in the next year or so, what we are going to do is it needs to be a closed lane, let's put it that way, where, for example, you're doing other work and then you leave the vehicle going on the lane. Whatever defect it finds, it actually seals. And it might be a moving section. As the vehicle moves, then you can reopen the one at the back, and that will depend on the curing time of the materials and so on. That's how I think we see in the short term. In the long term, we see this leaves the depot. You tell them, follow this path, find all the defects. But you need to talk to the lawyers and to the government to see when we can actually do this for real. Let's put it that way.
Okay, thank you.
I think we've got time for one more question. But whilst people are thinking of one more question, I would like to encourage people to stay for the next session, which is Bill Manby and Richard from Lincolnshire, who are talking about pothole hierarchy. So that will form very interesting beyond this session. Do we have any more questions or even a comment from Hertfordshire?
How proud of you to have the world record for the most cracks filled by an autonomous AI-powered vehicle in Hertfordshire?
Very proud, of course. No, it has been great working with you guys because we set the requirements with you, so that we were sure whatever we were developing were actually fit for market and it was meeting a real need. And then having the trial opportunities with you, I think it's been very, you know that we have learned a lot across the different, from one trial to the next. So I think it has been quite crucial for our development.
Yeah, I'd just like to add to that, actually, and thank you to Paula and Elkrig and everybody else who gets involved in these sort of trials. I've been involved in various innovations of materials for the last 30-odd years, and it's really important that we're able to get those trials within local authorities and look at them over the long term and look at how they perform, because otherwise innovations can stall if you can't get those early uses out there, because of course we all like to see an innovation where somebody's already done it before. So Hertfordshire, thank you very much. They've already done it. so if you're thinking this might be for us, give us a shout and let's come and see what we can do in your area and see what it looks like on the ground. Thank you.
Right, can we all please extend a grand thank you for Paolo and Mike and